Let's take a look at the following series and determine whether it converges or diverges. The series is n equals 2 to infinity of 1 over the natural log of n. So when I see the natural log function in a series, I often think either integral test or direct comparison test. Now the integral test really doesn't apply that well. It would be difficult to do the integral of this a sub n. So instead, let's use the direct comparison test. So let's talk then about the direct comparison test. So recall, the direct comparison test is where we're comparing our original series to another series. So the direct comparison test is when we compare one series to another series. Specifically, we use the notation a sub n and b sub n to denote our two series. So a sub n is our given series, and we're comparing it to b sub n. Now, one thing that's important with the direct comparison test is an order. What kind of order can we set up using the natural log function? Well, there is that inequality that we've stated before, that relationship that 1 is always smaller than the natural log of n, which is smaller than n, provided n is larger than e. And this is always true. Keeping that in mind, what that's going to do is using this basic inequality, we can then rewrite, shuffle it, use some algebra, and get our original series 1 over the natural log of n. How do we do that? Well, we just take the reciprocal. Let's take the reciprocal of each number. So if I take the reciprocal of 1, I get 1 over 1. If I take the reciprocal of 1 over the natural log of n, I get 1 over the natural log of n. If I take the reciprocal of n, I get 1 over n. And when we take the reciprocals of numbers, remember, the smaller numbers actually become larger, correct? And so the order of that inequality symbol has to flip. Now specifically, if I hone in and look here at this part of that inequality, I have now the basis of two series that I can compare. My original series, 1 over the natural log of n, is my a sub n series, right? That's 1 over the natural log of n. My new series that I'm comparing to is this series right here, 1 over n. That's going to be my b sub n series, and that's actually the series 1 over n, which is our, what is that? That's our harmonic series, remember? That's our harmonic series. And what do we know about a harmonic series? Harmonic series always diverge. Beautiful. So we have an order. We know what one of the series does that we're comparing to. And so what does the direct comparison tell us? Well, the direct comparison test tells us, recall, I do this with bubbles and ideas, so visually we have this series b sub n, and it's smaller than the other series, which is our original series, a sub n. And so if I know that b sub n diverges, it blows up and gets larger. And so if b sub n diverges, a sub n follows, and it has to diverge as well. So what does that mean? That means we're done. The direct comparison test tells us. So the direct comparison test tells us that since two things. First, we have an order, right? Since the series b sub n, which is the series 1 over n, is smaller than our original series a sub n, which is the series 1 over the natural log of n. So since our series 1 over n is smaller than our series 1 over the natural log of n, and moreover, that series 1 over n diverges, then it follows by the direct comparison test that our original series, a sub n, which is 1 over the natural log of n, also diverges. Whoops, excuse me here. That also diverges. That's it. That's all we need to do.